All right, MathHL, let's take a look at another induction problem. This time, the question is about divisibility, specifically the idea that we're looking to show that this expression represents a multiple of 7 for all positive integers. So that's what this means. So we're going to go through the normal steps of math induction to demonstrate that this is true. The first thing we want to do is write out the proposition that we're trying to show is true using math induction. This is usually just a restatement of what you're asked to prove using induction. So that's step one. Now we start the process of actually using the principle of math induction to prove this. So we need to show that a specific case is true. And so what that means is we're going to show that when n is equal to 1, that the proposition is true. Specifically, that p of 1 is true. So p of 1, we need to substitute into this expression. So this becomes 12 to the 1 plus 2 times 5 to the 0. And this is just 12 plus 2 times 1, which is 14. And this is a multiple of 7, which shows that p of 1 is true. The next part of math induction is to assume that p of k is true. And in words, or using our proposition, we can write a statement of what this means. Now let's talk for a second about this. This is saying on the left-hand side that 12 to the k plus 2 times 5 to the power k minus 1 is equal to 7m. Now this is the new piece for today's proofs. If this expression on the left-hand side is a multiple of 7, it means that it can be written as 7 times some constant, m, and m is an integer. And let's make sure that we are stating that it is positive integers. So 7 times some integer, we don't know what that integer is. We don't need to know. We just need to say specifically that it's 7 times some integer. The next step in math induction is to try to prove that for n equals k plus 1, p of k plus 1 is also true. Now, we don't know that it's true beforehand, but let's see what happens when we write out p of k plus 1. So this becomes, on the left-hand side, 12 to the k plus 1 plus 2 times 5. And I'm going to write this out. You don't have to, but I don't like to miss terms. So just to be clear, I'm going to write in k plus 1 minus 1 on the left-hand side. And I want to show that this is equal to 7 times some number m. Okay, and I don't know exactly what it is, so 7 times something, that is an integer. And I'm going to put that question mark in there because I'm trying to show that this is true. So let's not cross the equal sign. We don't have to do anything on both sides. Let's see if we can simplify what's on the left-hand side. So first thing, this becomes 12 to the k plus 1 plus 2 times 5 to the k, simplifying that expression, k plus 1 minus 1. And so 12 to the k plus 1 plus 2 times 5 to the k is our result. Now, let's notice that if this statement above is true, this is the original statement there, then we can actually make a little substitution for 12 to the k. From this, we can actually show that 12 to the k is equal to 7m minus 2 times 5 to the k minus 1. This time we can do something to both sides because this we are assuming is true. So we haven't broken any rules there. knowing this, this means that we can actually substitute this expression that we've just come up with in for 12 to the k. And so this right here, 12 to the k plus 1, is 12 to the k. Let's see that. It is 12 to the k times 12 plus 2 times 5 to the k. And so we can now substitute this other expression. So this becomes 12 times 7m minus 2 times 5 to the k minus 1. And then just bringing along that 2 times 5 to the k. And we can do a little bit of work here as well, because this over here, this 2 times 5 to the k minus 1, we can, let's see. This right here, this 5 to the k, I can write this as 5 to the k minus 1 times 5. And you might wonder why we would want to do that, but I'm looking over here at the k minus 1 exponent, and I would like to make this 5 to the k have a 5 to the k minus 1 in it. So I'm going to take this and substitute it into this expression. So rewrite our result. So 12 times 7m minus 2 times 5 to the k minus 1 plus 2 times 5 to the k minus 1. And now I can continue doing some work here because I can actually distribute this 12. So this is 12 times 7m minus 24 times 5 to the k minus 1 plus 10 times 5 to the k minus 1. And I can do a little simplification here because these are like terms. And so I end up with 12 times 7m, just bringing that down, and then minus 14 times 5 to the k minus 1. And now I'm going to do a little bit of work here, just rewriting this. I can factor out a 7 from each of these terms. So this becomes 12m minus 2 times 5 to the k minus 1. And we've actually done this because this whole thing is guaranteed to be an integer. And so since this whole thing right here is an integer, then this expression is 7 times an integer. And that right there, since we have 7 times an integer, this means that we have proven what we were looking to do, which is specifically that 12 to the k times 12, oopsies, sorry. 12 to the, this expression way up here, where we started, 12 to the k plus 1 plus 2 times 5 to the k. So 12 to the k plus 1 plus 2 times 5, this whole expression right here is therefore a multiple of 7. So 12 to the k plus 1 plus 2 times 5 to the k is a multiple of 7. So last step of math induction, p of k is true, implies that p of k plus 1 is true, and that first thing we did, p of 1 is true. So by induction, we know that p of n, that original proposition, is true. And that's it.